After the end of World War II, the United States of America faced a new geopolitical reality in which nuclear weapons became the determining factor of military superiority. The growing influence of the U.S. Air Force, reinforced by the development and successful use of the atomic bomb, has created an unprecedented situation within American military influence. The Navy, which has traditionally played a key role in projecting American power around the world, suddenly found itself in danger of losing its strategic importance. This intense interagency competition led to the birth of one of the most ambitious and technologically daring programs in the history of military aviation, the creation of seaplane strike forces capable of carrying nuclear weapons. The catalyst for the development of this revolutionary concept was the Pentagon's decision to give preference to the Air Force's B-36 strategic bomber instead of supporting the Navy's ambitious project to build the nuclear supercarrier USS United States. This decision was perceived by the Navy's leadership as a direct threat to the future of naval aviation and the Navy's participation in the country's nuclear deterrent system. If the Pentagon was not going to finance new aircraft carriers as part of the nuclear arsenal, the Navy decided to completely abandon them in its nuclear weapons planning and take an alternative path. The answer was the concept of seaplane strike forces, known as the Seaplane Striking Force or SSF. This program envisioned the creation of a fleet of long-range jet seaplanes that could carry out strategic bombing missions, reconnaissance operations, and provide support without the need for traditional aircraft carriers or land bases. The advantages of this approach seemed revolutionary. Seaplanes could operate from any suitable water surface, remain undetected by most existing radar systems, and had unprecedented operational flexibility. Naval strategy theorists even assumed that the successful implementation of the program would make traditional aircraft carriers obsolete. In 1948, the Navy announced an open competition to develop a supersonic seaplane fighter capable of traveling long distances without the need for specialized bases or aircraft carriers. The terms of reference were extremely ambitious. The planes had to take off and land on the water, approach ships and submarines only to replenish fuel, ammunition and carry out maintenance. The decision to develop such aircraft was partly dictated by the serious problems faced by the fleet when landing the latest heavy supersonic jets on existing aircraft carriers. Two of the largest aircraft manufacturing companies of that time responded to the competition. Glenn L. Martin Company presented its P-6M Seamaster concept, while Convair offered several projects at once: F-2Y Dart, XFY-1 Pogo and R-3Y Tradewind. Each of these aircraft represented a unique engineering solution that embodied different approaches to solving the task set. Convair's XFY-1 Pogo was perhaps the most radical and least promising of all the proposals. This tail-mounted vertical takeoff and landing aircraft was designed to take off and land on small offshore platforms or ship decks. The design included small landing wheels at the ends of the wings and vertical stabilizers that allowed the car to stand vertically. The power plant consisted of two massive Allison T-38 turboprop engines with two 3-bladed propellers, developing a total output of 5,500 horsepower. However, Pogo had three fatal flaws that predestined the closure of the program shortly after the prototyping stage. Firstly, vertical takeoffs and landings turned out to be extremely unusual and difficult for pilots who are used to seeing the landing pad during landing. The rear-view mirrors proposed as a solution turned out to be completely ineffective. Secondly, manufacturers have not been able to create a reliable enough engine capable of providing the necessary power for vertical takeoff. Thirdly, the maximum speed of the Pogo was only about 550 miles per hour, which made it too slow compared to Soviet MiG jet fighters. The lack of air brakes and spoilers further complicated the control of the aircraft. After about 80 test flights, the program was closed in 1955. The only surviving prototype is now in the National Air and Space Museum in Maryland. The F-2Y Dart became Convair's main offering for the 1948 competition. It was a turbojet aircraft with a triangular wing and a waterproof hull, capable of taking off from the water on two retractable hydrolides. In 1951, the company was awarded a contract to build two prototypes. At rest, the aircraft floated on its body, with the edges of the wings touching the water. The first prototype had two skis that extended when reaching a speed of 10 miles per hour during takeoff. The second prototype was equipped with a single ski, which unexpectedly showed better test results. The first Sea Dart flight took place in San Diego Bay in 1953. Interestingly, an accidental short-term separation from the water occurred back in January during a planned taxiing, and the official first flight took place only in April. Due to production limitations, the engines were seriously underperforming according to their stated characteristics, and the hydroloop system caused severe vibration during takeoff and landing, which made flights extremely dangerous. A fatal incident occurred on November 4, 1954, when test pilot Charles Richboard, a World War II veteran, died during a test flight over San Diego Bay. According to reports, in an effort to reach supersonic speeds, he took the engines beyond the permissible operating modes, which led to the destruction of the aircraft in the air. This tragedy effectively put an end to the Sea Dart program. Although some tests continued for some time, mass production was finally cancelled. The R3Y Tradewind became Convair's third offering and the only one to reach limited series production. Its design used many of the technologies developed for Sea Dart, but with a more conservative turboprop powerplant. In May 1946, two versions of this flying boat were ordered, one for transporting passengers, the other for cargo. The aircraft was named R3Y Tradewind and was equipped with improved engines, cabin sound insulation and an air conditioning system. Its cargo capacity was an impressive 25 tons or 103 passengers. 5 R3Y1 aircraft were built to transport troops and fuel, as well as 6 additional R3Y2 aircraft with a raised nose and a high cabin designed to carry heavy loads. It was assumed that these machines would work as flying amphibious ships, but keeping the aircraft in a stable position during loading and unloading proved to be almost impossible. As a result, most of these models have been converted into air tankers for in-flight hose cone refueling. Despite the challenges, Tradewind has achieved some impressive results. In 1954, he set a speed record for seaplanes, flying at 403 miles per hour during a transcontinental flight using high-altitude jet streams, an achievement that no seaplane had ever repeated before. A record was also set for the simultaneous refueling of 4 fighters. Unfortunately, due to the chronic unreliability of the engines, only 13 copies were produced. The Martin P-6M Seamaster was recognized by the Navy as the most promising of all the submitted projects. The first prototype XP6M1 made its maiden flight on July 14, 1955. It was a large flying boat with 4 Allison J71A4 turbojet engines located at the wing roots on top of the fuselage. Secret tests in the Chesapeake Bay revealed a serious problem. The afterburners could literally meld the aircraft body due to the engines being too close to the fuselage. The redesigned prototype was launched in November 1955 and showed some encouraging results, but was lost on December 7 of the same year after an in-flight control system failure. After a series of additional tests, the T-tail and flight control systems were significantly modified to prevent catastrophic failures, and ejection seats were added. These seats saved the lives of the crew just 6 months after installation, when the Seamaster prototype began experiencing severe vibration during a test flight. 4 crew members successfully ejected while the plane was literally falling apart in the air. Tests of the improved Seamaster continued with bombing, mining, navigation and reconnaissance flights. 24 P-6M2 aircraft were ordered, and the first of them was delivered to the fleet in early 1959. The production model used more powerful Pratt & Whitney J75P2 turbojet engines without afterburners, capable of accelerating the seaplane to 650 miles per hour at low altitude. The Seamaster could reach speeds of 0.9 Mach, which was faster than the new B-52 strategic bomber used by the Air Force. This gave the Navy a tempting opportunity to gain an advantage in delivering the American nuclear arsenal. The Seamaster's weapons plans were impressive. They were supposed to be equipped with either 2 Mk-11 nuclear bombs with a capacity of 30 kilotons each, or 1 B-28 thermonuclear bomb with an explosive equivalent of 1 megaton. The aircraft was promising and impressive, but not without serious technical problems. At speeds above Mach 0.8, the car experienced intense shaking. When landing on water, engine surges often occurred when the upper floats were buried in the water, creating a risk of overturning the aircraft. The problems were so serious that the aircraft was temporarily excluded from the fleet until technical solutions were found. However, the ambitious goals of the nuclear seaplane project were abandoned before the Seamaster could be brought to perfection. The parallel development of ballistic missile submarine technology has achieved what the seaplane project could not achieve. It has returned the Navy to America's nuclear deterrent system, eliminating the need for nuclear-powered seaplane strike forces. The possibility of continuing to use the Seamaster as a mine layer was considered, but the program proved to be too expensive and could not meet the long-term strategic goals of the fleet. The initial order for 24 vehicles was successively reduced, first to 18, then to 8, until the Navy finally cancelled the project in August 1959. By this point, an astronomical $400 million had been spent on the program, which is equivalent to about $2.5 billion in 2004 prices. The Glenn L. Martin Company made a desperate attempt to save the project by offering airlines a civilian version of an 8-engine aircraft called Sea Mistress. This initiative turned out to be such a failure that the company completely excluded the design and production of aircraft from its activities, switching its focus to the development of missiles and military electronics. The remaining Seamasters were disassembled for spare parts, putting an end to the ambitious program. The advent of the era of ballistic missiles with their efficiency and relatively low cost, the successful development of ballistic missile submarines and the continuous improvement of aircraft carriers led to a complete loss of naval interest in seaplanes. Neither Convair nor Glenn L. Martin Company were able to present something so revolutionary that it would justify the huge cost of the program. Within the Navy itself, senior deck aviation officers outranked and influenced those who supported the concept of seaplanes in the 1950s. In addition, ballistic missiles made it possible to launch nuclear strikes without the participation of crews, which significantly reduced the risks to personnel. Seaplanes, which were supposed to conquer the world and revolutionize naval strategy, suffered a complete fiasco, and the idea of creating a seaplane strike force was finally abandoned, leaving behind only a few museum exhibits and important lessons about the limits of technological ambitions in the rapidly changing strategic environment of the Cold War.